we know that M is lighter than A is lighter than the B. So I'll assume that A will rebound with a speed, and the B what will happen will acquire a speed V2. Quotient of distribution between the balls is 1/2. Between the ball and the wall is 1. Take like this. So you have to write in sequence order. You have to write equation. So initial momentum. This is for first diagram. I'll put this one for event 1. Mu is equal to minus mv1 plus 2mv2, or u minus v1 plus 2v2. Towards right, let it be positive. So quotient of restitution is how much? Directly I'm writing it 1/2 v2 plus v2 minus of minus v1 by plus u minus 0. So v2 plus v1 or u by 2 is equal to v2 plus v1. Add up these two equations. When you add up these two, we'll get 3v2 equal to 3u by 2, or v2 equal to u by 2 will get 3v2 equal to 3u by 2, and v2 is equal to how much? Will be u by 2. What about v1? Substitute here. v2 equal to u by 2. v1 how much it will be? 0, no? So just after impact, the first ball will come to rest here, in fact. So what is the sequence that occurs? This will be at rest, and this will continue to move with a speed v2. And the collision between the wall and the ball is elastic, no, and is equal to 1. So what will happen to this? This will rebound with the same speed. Now this will come and collide, and finally is asking what will be the velocity of the balls. So it should be after collision. So this is 2m. So let the velocity of this be VA, let this be VB. Apply now conservation of linear momentum for this is second event. Sorry, this is second event that occurred, that is between the ball B and the wall. Now there is a third event. As there is elastic collision, it will rebound with the same speed. Now take help of this. Between second and third event, you apply conservation of linear momentum. So 2mv is equal to minus 2mvb minus mva. All this is equal to 2v2 2vb plus va. Quotient of restitution formula. Between the balls, it is 1/2 minus vb minus of va. This is at rest. This will be 0 minus of v2. I just continued the same thing. Anything that is towards right, I took positive. Throughout the problem, I'm maintaining the same condition. If you want for second and third, you can change that. Okay, let's continue that one again. So this should be equal to negative sign. You can take common and solve it. So solving equation 3 and 4. So this will be v2 by 2 should be equal to vb minus.
Sir, VA minus VB on the sir.
Sir, VA minus VB, sir.
VA minus VB, yeah. So V2 by 2, VA minus VB. Yeah. V2 value we know it is equal to U by 2. So this will become U by 2 equal to VA minus VB. Call this equation 4. Solve equation 3 and 4. We'll get VA and VB. There will be the speed of the objects after impact. You should not apply directly from the first and third. One more event occurred between. Are you trying to make a guess? The ball B has to collide with the wall. That you cannot skip out. You cannot directly write the conventional term in this diagram and for this diagram. Are you getting no? You cannot write between this initial and the final. Here one more event occurred. The second event, what happened, cannot be so cannot be, you can say, you cannot escape it or you cannot skip this. So in between, so students open to save time, no directly answer, okay, this is finally this what happens. I'll apply from here, initial momentum from this diagram, or say this one. Initial momentum from this diagram to directly this diagram. No. So in between this event, what when you cannot skip. That's what the meaning of this question here. The rest of everything is very simple. Writing quotient of restitution and this particular condition of linear momentum. Why will A come to rest? Because of the equation, no? Why A will come to rest means what I should say. B1 I got 0. What, you don't believe in these equations? What all we did, it's not correct. Okay, no. So is it okay? VA, VB value, anybody?
Sir, VA is U by 2, sir. VB is U by 4.
Yes, sir. Yes, sir.
Yeah, okay, fine, yeah. Okay, this will be our final.